Today we will be looking at LFM Software's latest piece of innovative software, LFM Server 4.2. As some of the people on the call are fairly new to LFM software, I'd like to take a couple of minutes to introduce LFM's goals. LFM have been present within the laser scanning industry for a number of years, pioneers of several technologies still utilised by companies today. Our core goal is to offer solutions to the plant, oil and gas, AEC and BIM industries. To achieve this goal, we focus on two key strategies. Firstly, we provide solutions which span the entire life cycle of the laser scan data. And secondly, we maintain neutrality for both data handling from the laser scanner vendors and providing LFM deliverables compatible with all the leading CAD packages. This second strategy we call being open on the inputs and open on the outputs. These strategies are underpinned by our strong heritage in the laser scanning industry. From day one, we have taken an intelligent approach to handling your laser scan data, providing the ability to handle a limitless number of scans per project, as well as providing an intelligent engineering deliverable to your end clients. LFM software is continuously developed in alignment with these strategies to provide more intelligence, more capabilities, and more efficiency for our end users. The 4.2 release represents a significant step in this process, with vastly improved integration between our products at their core. For those on the call who are already familiar with our products, you may recognise these product names. What this latest release brings is the tighter integration of these products into one LFM environment. The following diagram represents how these products now sit within this new unified environment called LFM Server. It is important to note that this does not mean our customers have to purchase one product. We still offer significant flexibility of our product capabilities. This diagram is purely used to demonstrate the tighter integration, which provides significant time and cost savings, which you will see through the live demonstration. For those service providers on the call who are looking to enhance their delivery to their end client, this integration offers great opportunities. LFM Server 4.2 contains within it two operating modes, Server Mode and Gateway Mode. LFM Server's Server Mode is the most advanced solution available for accessing pre-registered laser scan data and working with it directly in 3D CAD systems. LFM Server's Gateway Mode provides unparalleled and extensive connectivity to terrestrial 3D laser scanners, as well as importing other 3D captured formats, supporting mobile, handheld or aerial scanners. LFM Gateway also enables data export in open industry standard formats. Due to our audience today being primarily service providers, we will be focusing on LFM Server's Gateway Mode, which exploits the latest advances in multi-threaded and non-blocking computer hardware architecture. Multiple actions can be performed simultaneously for a more efficient workflow, which is something that you will see in the live demonstration. We will now be heading towards our live demonstration. To introduce you to the project we'll be working with today, I would like to give you an overview. The project is a close representation to the average projects which are often carried out today. It is a large site being scanned by several different service providers at different dates over the last year. With this project, the engineering users want an as-built representation for future work, such as revamp projects and decommissioning. The owner-operators want the as-built information for asset management. The area was scanned in phases, with variants in scanner types used. The service providers have used their preferred laser scanner, with a mix between mobile and terrestrial scanners being used. Our goal today is to consolidate all this laser scan data into one project, so that the engineers and the owner-operators have the data to carry out their own tasks. So let's look at the project layout. As mentioned before, our project today is a large site. Unit 10 is our first area of the project, which was scanned in two phases. The initial phase concentrated on grade level scanning, whereas the second phase concentrated on enhancing these initial scans by scanning upper floors. We have a mix of registered and unregistered files. These phases of data will be a good opportunity for us to demonstrate LFM Server Gateway Mode's rapid and fluid registration process. Phase 3 of scanning focused on Unit 11, which was carried out by a different service provider who has scanned the site with a Faro scanner. They provided the scans pre-registered in Faro Scene in FLS format. The scanning of Unit 12 was Phase 4 and is the largest area to be scanned. Therefore, a scanner mounted on a vehicle was used. This data is also pre-registered. This phase will be a great example of how LFM server can accept data from various source of scanner types. The last section of our data is the B64 boiler room, which is composed of unregistered Faro colour scans. In the interest of time during this demo, these Faro scans have been converted into ZFC format. In this location, we will be using LFM server Gateway Mode's intercloud registration feature. Now that we have a general overview of the project we will be working with, I would like to hand you over to Jenny Koppel, one of our application consultants, who will be giving us a live demonstration of this latest version of LFM server.
Okay, thank you, Ryan. So firstly, we're going to look at Unit 10, and as Ryan said, this is split into two phases. Phase 1 has already been converted and registered to the survey. Now we will convert the ZNF scans from Phase 2 and register them against the same survey. Once we have registered the scans, we will look at the quality of the registration using LFM's extensive QA tools. So here we have our project, and as we can see, the registered scans from Phase 1 are in this group here. I've also created a new group to handle the survey. So we will add the rest of the Phase 2 scans. We can specify the desired location for the converted images. And once this, the scans are added to the project and begin to convert. As Ryan mentioned, there are two new time-saving features within LFM Server 4.2. The first is multi-threaded scan conversion, which, as we can see here, allows us to convert more than one scan at a time. The number of simultaneous conversions is based on the number of cores available on the machine minus 1. So in this example, we have a 4-core machine, and so we're converting 3 scans at once. The next time-saving feature is the non-blocking technology. If any of you are familiar with the old software, you will know that you had to convert all the scans. So for example, if you had a project containing 500 scans, you would have to wait for all those 500 scans to finish converting before you could start the registration process. This non-blocking technology means that once an individual scan has finished converting, that scan can be accessed instantly for registration. In the interest of time, we have already converted 2 of the scans for this phase, and these scans have been loaded in the bubble view in 3D. If I click on scan 1, the points from this scan are highlighted yellow, and the same with scan 2. You can see that these 2 areas here and here are both faces of the same vessel, showing that the scans are unregistered. So now I'll move into the bubble view, and I'll begin to register the first scan. So I'll go with our Pick Targets button here at the top. I will click on the centre of the scan, in the centre of the target, and enter the target name. And again for the second target. What we will see now is that LFM's target prediction algorithm has begun. This gives us a list of predicted targets within this scan based on the survey. Okay. I can cycle through this list using the green tick or red cross to accept and reject these targets based on whether we can see them accurately in the scan. So I'll move on to scan 2 and do the same. So I pick the centre of the first target and enter the name. Just give the WebEx a second to catch up again. I think there's a bit of a delay between what I'm seeing on my screen and what you're seeing, so just give us a second. Okay, and now I've identified the second target. Again, our target prediction system has been, and again we can cycle through this list of targets, accepting or rejecting them based on whether we can see them. Okay, so we've got an adequate number of targets in both of these scans now. And if I return to the 3D and click on the first scan and the points turn yellow, and then the second scan and points turn yellow, we can see that these scans are now registered. Whilst we've been registering these scans, the third scan has finished converting. And I'm going to load that scan, and we're going to register this view. For those of you who are familiar with LFM server, you may recognise this. The tile view allows us to see up to 4 different viewpoints at once. In this example, I will have the D view covering the bottom 2 windows, the bubble view for scan 3 covering the top right window, and the registration status tab, which we'll explain shortly, in the top left window. Okay. So again, I will pick the first 2 targets. And then cycle through the predicted targets, again accepting or rejecting based on whether we can see them in the scan. When we get to the end of this target prediction list, LFM informs us that there are no more predicted targets for this scan. So now we need to check the quality of the registration. We can do this in 3 ways: via the traffic lights, the registration status tab, and the network view. The traffic light system comprises of 2 icons. The diamond icon on the left represents the interdistance between the targets within the scan compared to the interdistances between the targets within the survey. The circle icon represents the error between the target in the scan and the same target within the survey. These traffic lights are configurable. If I go into our options window for a second, we can see here that this project is set to 3 mm for the amber threshold and 6 mm for the red threshold. This means that any targets with an error between 0 and 3 mm will be green, between 3 and 6 mm will be amber, and above 6 mm will be red. We can change these options and the traffic lights will update live. There is no need to manually re-register the scan. So I'll just put those back. The next QA tool that I would like to show you is the registration status tab. If I add our registered scans to the registration status tab, we can expand each scan to see a list of targets contributing to the scan and further information about these targets, such as the XYZ position, the error, and the correspondence, whether the target relates to the bundle or the survey. If I right-click in the registration status tab, I can filter the view by red and amber traffic lights or red only. This helps us to see which targets need our attention. We can also filter the targets by error, showing which target has the highest error, and to investigate whether it should be disregarded. If we want to disregard a target, we can simply expand that target to show the individual picks making up the target, and select Do Not Use for registration on an individual pick. This will update the registration for that scan automatically. Again, there is no need to manually register the scan as required with the old software LFM register. The last QA tool I would like to show you is the network view. So I'm just going to move into the 3D window for a second. Select both groups. Go into the ortho view. And I'm just going to turn the points off for a second. We can see a series of lines on the screen now. Each line represents a target, showing the line of sight from the scanner to the target. Each line is the colour of the relevant traffic light, and any dotted lines represent targets that have Do Not Use for registration applied. This network view allows us to see the overall position of the targets to ensure there isn't a spread and see if there are any areas of concern. For example, if all the lines connected to one target are red, it could be that that target has been misplaced within the survey, and if we know this, we can remove that target from the survey. I'm going to hand back to Ryan for a brief recap before we move on to the next stage.
Okay, thank you, Jenny. So, we have just seen during the part of the demonstration the LFM server allows multi-threaded and non-blocking scan conversions. This means that efficiency is increased as tasks can be completed alongside multiple scan conversions. We also saw the speed and efficiency the LFM server allows registration of scans against existing survey. Target prediction minimises the time required to register scans individually. We also saw the tile view. This view allows the user to maximise on their visual working space, increasing their productivity when performing tasks. We also saw the varied QA tools, which are a new addition to LFM server, including the network view, which Jenny demonstrated. This allows users to view the relationship between scans and targets, as well as the quality of their respective picks. Lastly, we saw the registration tab and configurable traffic light system, which gives in-depth information on the registration quality. Users are able to analyse their registration as well as run what-if scenarios. This means that users can ensure the quality of their registration is high before proceeding to the next stage. Next, we'll be able to demonstrate our ability to import various formats of scans, as well as pre-registered scans. We will also be seeing LFM server gateway modes inter-cloud registration being performed on some scans, aligning them using control points. Lastly, we will also be looking at LFM server gateway modes deliverables, looking at exporting in industry standard neutral formats, as well as generating LFM server datasets and LFM NetView projects. So I'd like to pass you back to Jenny just now.
Okay, thanks again, Ryan. So in this part of the demo, we will show that we can use scans from different laser scanners, in this case, the Faro Focus. So I've created a new group here to house these scans, and I'm going to go ahead and import the FLS files. Again, I can specify the folder where I want the images to be saved. And the scans should now be added and start to convert. Whilst these scans are converting, we will move on to the next phase of the project, and we'll come back to these scans once they've been converted to review the results. The last phase of this project is the boiler room. This consists of 3 colour Faro scans that we will register via intercloud registration. For those of you who are familiar with the old LFM register, you will know that we can identify common points between the scans to use as targets, for example, marks on walls or corners of signs. Whilst these tools are still available in LFM Server 4.2 Gateway mode, today we will be showing the new scan manipulation tool. This allows us to drag the scans into roughly the correct position and then reposition using LFM's intercloud registration algorithm. So here we have the group containing the 3 pre-converted scans, and if we review these in the 3D, we can see that they are unregistered. So I'm going to move scans 1 and 3 to match the position of scan 2. To do this, I will right click on the first scan and select Manipulate. This allows me to rotate and move the scan into roughly the correct position. So just give me a second whilst we do this. And the same with scan 3. Once we've done this, we can refine the registration by running the Cloud All function. This will start LFM's intercloud algorithm, which compares and matches similar area within the point cloud. I will zoom into the points, which you should see moving around during this process. If I click on the group node, we can see information about the intercloud process. We can see the maximum number of iterations, which is specified at the start of the process, the current iteration, so we can see how far along in the process we are, the number of points being used, and this will increase as the process goes on, using more and more points to refine the registration, and the lock distance, which represents the error. So now the intercloud process is complete, we can see, if I zoom out, that the scans are successfully registered. Next, we will align the data by picking control points. I will pick the first point in scan 1, so we'll just load the bubble view for this scan. Pick our first control point here. And I'm going to pick the second control point in scan 3. I'll just give that a second to load. Along the other end of the same wall that we picked in scan 1, sorry. Once the control points have been picked, we can see that these appear under the group node. And we can select these control points and align them either east or north. If I move back to the 3D view, that these have now been aligned based on the control points picked. The registration of the boiler room is complete, so let's go back to one of the scans from Unit 11 that we were converting earlier to see the results. Here we can see that the scan has successfully converted. Now that we have all aspects of this project converted and registered, we will look at the different deliverable options. These consist of individual scan export to PTX and E57, LFM server dataset generation, and LFM NetView project creation. In the interest of time, we will not show you the actual execution of these options live, but will show you the way to access these options via the LFM server interface. For this example, I will use the boiler room scans. The export scans option on this group, I can see the export options available. We can export these scans in PTX or E57 format, and we can export to a single or multiple files. So in this example, if I choose single file, all 3 scans will be saved to one PTX or one E57 file. If I choose multiple, we would have 3 separate PTXs or 3 separate E57 files. Next, we have LFM server dataset generation. This is where the tighter integration that Ryan spoke about during the introduction becomes prevalent. For those of you familiar with the old software, you will know that you needed to convert the scans using LFM Scan Gateway, then register the scans using a separate package called LFM Register, and then generate the LFM server dataset in yet another piece of software, LFM Server. Now the user can do all these things in one interface. We can access the generation settings window by right-clicking on the group and selecting Generation Settings. Here we need to specify the destination folder and the intermediate folder. We also have options for generating within a specific volume, density, and incorporating colour information if it is available. Once all these options are filled in and the desired group is selected, if we go to the Generation tab, once all the options are filled in, the Dataset button would become available to allow us to create the LFM server dataset. Lastly, we have LFM NetView project creation. This function is accessed by right-clicking on the desired group and selecting Prepare for NetView. This will bring up the NetView project creation wizard where we can specify the desired options for our NetView project.
So LFM supports scan formats from various scan vendors, even in pre-registered format. As mentioned at the beginning, we aim to be open on the inputs and open on the outputs. We also saw the ability to manually manipulate scans and then perform intercloud registration on the scans to register without a survey. In addition to the intercloud registration, we also aligned the data utilising control points. As you saw, this is a very easy process. Lastly, we saw the various deliverables that LFM Server Gateway Mode has to offer. We showed the ability to export in industry standard neutral formats, as well as the ability to generate LFM server datasets and LFM Server NetView projects. I'd just like to hand you back to Jenny now, who's going to show you the last deliverable.
Okay, thanks Ryan. So here is our completed project in server mode. We can see the 4 different areas. Unit 12 here, which was scanned with a mobile scanner. Unit 10 here, which consisted of ZNF scans that we registered against a survey. Unit 11 here, which was pre-registered data provided by a different surveying company. And the boiler room over here, which we registered using the intercloud registration tools.